Hello everyone, welcome back to the channel. In this part 2 of this video series about the 13.8 volt DC power stabilizer, we're going to cover a very important part for us ham radio operators. We're going to check some DIY tools for RFI checking. We're going to look at an spectrum analyzing software that is free. We're going to look tools verification, so putting all these together and ensure that it's actually checking for RFI. Once we do that, we're going to move into RFI checks on different power supplies and RFI checks with the radio, and then we're going to compare the results with and without the stabilizer on the power chain for our radios. So let's jump right into this experiment. Here I have two of the pieces that we are going to use to measure the RFI from our stabilizer, from the input and the output of our stabilizer. So the two parts that I have here out of the three parts that we need are this SDR receiver. So inside this secret box, we have this SDR receiver that goes connected to the computer through that USB-C port. We have this probe that I built. This is a homemade RFI probe, and I'm gonna show you in a moment how this was built. It has a coaxial cable, and at the end it has the SMA connector that goes into the SDR receiver. In this end is simply a loop of coax, and I'm going to show you now how this was put together. So I was watching this video from EE Vlog, and I found that it's very easy to make this probe on your own, like a DIY version. In his video, he shows also that it performs exactly the same as one purchase. To put it together, so you take one end of the coax, and at the very end you connect the braid and the central conductor, and that piece goes soldered into the braid, as you can see here in the top of the picture. Then more or less at the middle of the loop, cut the braid, and you make a small gap on the braid that you have to remove, and that uncovered place will be the picking point of the probe for the RFI, and this is very precise to pinpoint exactly from where the RFI is coming from. At the end, he ended up covering his probe with this yellow rubber paint, because he used a coax with exposed braid, but in my case the coax has the black jacket, so I didn't have to do this. On the top of the picture here, you can see a probe that you can buy very cheap from AliExpress, or you can make your own with a piece of coax and terminate it in a SMA connector. The other thing that I have in mind, which also he put it in his own probe, is at the end, after the handle, I have a ferrite bead that I run a couple of turns inside the bead here. This is just to prevent any other interference coming into the cable that you don't want. You just want the RFI to be picked from the tip. You can see here under the shrink wrap that I put on the top, the part that I removed the braid from the coax is the little piece that goes from here to here, is the part that I removed the braid from the coax. So now let me show you the third piece for all this to work, which is the software part. So this is the piece of software that we are going to use, is called RSP Spectrum Analyzer. It's a free software for Windows only. I'm capturing the output of that laptop This software allows you to use that SDR receiver attached to the probe that I show you on the first part as a very cheap and simple spectrum analyzer. As you can see here on the setting on the top right corner of the screen, I have set up a 20 megahertz span starting from 3 megahertz and going all up to 23 megahertz. That will cover the bands for 80 meters up to 15 meters in all this spectrum that we can see here on the screen. In the next part, I'm going to split the screen. I'm going to show you on the top part of the screen devices under test, and you will see in here on the spectrum analyzer how the SDR is picking the noise from the different sources. We're going to use that first to see how everything works, and then after that we're going to take a look at the stabilizer input and output. And now for this part of the video, what we are going to do is just do a simple test of the probe and the spectrum analyzer, just prove to you that everything that we are measuring in the way that we are measuring is working. The power supply doesn't have any load attached. As you can see, the terminals are here, don't have any load. It's set up at 12.6 volts, but there is zero current coming out of this power supply. I'm going to move the yellow point of the probe close to this back boost converter device, similar to the one that we use here in this metallic silver box. Is a similar device, right? So we're going to put it here close, and you can see immediately on the screen on the spectrum analyzer the noise coming into the image. So I'm going to remove it, and you can see the noise is going away. I'm going to bring it back in, and you can see the noise all over the spectrum. Remember, this range of the spectrum goes from 3 megahertz to 23 megahertz, and you can see the noise that this little device is putting across the entire spectrum when I bring the tip of the probe close to this metal sink for hearing dissipation. So now I'm going to do the same, and I'm going to come close to the bottom black box, which has the power supply that fits that converter. You can see noise that the black box at the bottom is making. If I put the probe beside the input of the power supply, you can see all this noise jumping all over the place on the spectrum analyzer. When I take the probe out, everything goes back to normal. This is the floor or base noise that right now is picking the probe. So as you can see, the system for testing is working. We can specifically see in what part of the spectrum the device is generating noise. And now we are going to use this power supply, and we're going to measure with the same system this power supply that we put in the part 1 of this series, the building of this stabilizer for 13.8 volts. What we have on the bench in this moment, so we have our stabilizer connected to a 12 volts battery that is source of power that is absolutely no noise. The battery is absolutely quiet. With that, we're gonna feed our stabilizer. The stabilizer is gonna work because it's gonna bring these 12 volts to the 13.75 volts that we use at the output. So it's gonna be working. And then with this clean power input, we're gonna see if the stabilizer itself is generating any noise, and if that noise generated is coming out through here through the output. To make the stabilizer do some work, I connected our load here, these two resistors, 100 watt resistors. Those are gonna consume 2.3 amps from the power supply, and we're gonna use that also just to see if there are more or less noise coming out once the stabilizer has some load. So let's get started. Let's turn on first the input. So now we have in our input on, and we're going to start measuring the input first. It should be absolutely flat, so similar here. You can see below there is some noise. I'm going to remove the probe, you will see that noise is going away. I'm going to put the probe close to this, and you see that the noise is coming back. So that is noise that, of course, is generated inside this silver box, the stabilizer. So we're going to move a little bit further inside the loop here. We see the noise is still present. At a very low frequency, is not across the entire range like we saw with the previous power supply. You can see here is always around 4 megahertz, I would say. Yeah, the peaks are marking 4 megahertz. So we can see, even we are feeding this with a 12-volt battery, there is some noise, and the noise is generated by the stabilizer itself, because of course inside it has a switching power supply, right? So now the output is off. Here we can see there is no consumption, and this is connected, but it's not turned on yet. So we're going to turn this on, and first we're going to measure if there are more noise in this section, in this exposed cable here outside the box. And after that, we're going to measure here after the alligator clips to see if through these cables are any RFI coming out of our stabilizer. So let's turn it on first. Now that this is on, consuming 2.26 amps, let's see if we have similar, more or less noise. I will say is about the same, maybe a little bit higher, right in the middle of that grouping. We can simply turn it off and on just to see if there's any difference. Yeah, it goes down around 10 dB when we turn it off. Let me turn it back on. Let me see if this is not getting too hot. Now this is the important part. Let's measure here. Let's measure on the cables, and the positive seems to be clean so far. Yeah, there are no noise sweeping on the positive cable here. This is pretty good. This is pretty encouraging, this test. That means that the filtering that we put inside is doing its work. So I bring the probe in and out to the negative, and we see that still there is not noise like we showed before in the 4 megahertz range. Nothing. Let me check the other way. Absolutely no noise coming out of here. So that means the filters are doing what it's supposed to do, the filter inside this box. So now, in the next test, we are going to replace this battery that we know that it has no noise with a power supply that I have here on my bench that I know is very, very noisy. It's not the same one that I show you at the beginning. It's a different one. That one is a 100 amps power supply that I have that provides 13.75 volts. But I'm not using this for my radios. Usually I have it off because it's a noisy power supply. Now, with this box, the voltage is not going to change. The input and the output voltage will be the same. But with all the filtering that we put inside, let's see if at the output of this box, we have a clean 13.75 volts. So I have hook up this power supply, Power Max 13.6 volts, 100 amps power supply, which I pick up on the thrift store, and it was no working. It was all blown, the transistors and all that. So I got the replacement transistors and I fixed it. I put it back together and I tested. And you can see here the maximum that I can test, it was 30 amps because I don't have any load bigger than that. So if you remember from the previous video, I show a load that I built with the halogen 12 volts lamps. I built this load to test this power supply when I fix it. This power supply is amazing. It delivers 100 amps. But the problem, as you can see on the bottom right corner of the screen, the power supply without the box, the filtering is absolutely non-existent. It's pretty bad. It has only that toroid with coil with a couple of capacitors, and that's it. And that is absolutely nothing to remove the noise from this switching power supply. So this is one of the reasons that after fixing it and putting it here on the bench, I never use it much because I didn't like the noise at the output. And we'll see now if we can put it to use with this stabilizer converter from the previous video. So let's hook it up and let's start doing the tests. Everything is now connected. In here I have the 100 amps power supply connected into the stabilizer. In here I have 12 volt car light connected in here to get some load into the device. This provides approximately about 2 amps, 2.3 amps, if I remember correctly, of consumption. That was sufficient to make sure everything is pulling and is working, like all the switching and all that. And we're gonna once we turn it on, we're gonna start measuring in the input, in here in the exposed cables from the converter, and in the output, and we'll see if we have any RFI either from the source, from the original power supply providing all the energy, or from the converter coming out here before this ferrite bead, right? We're gonna measure here to see if we have any leakage of RFI. So let's turn it on. Now everything is on. The power supply is providing 13.85 volts. Now the load is also on. We can see that the car light is consuming 2.23 amps. It's a nice load to test RFI. This load, if it's any RFI anywhere, it should be very apparent. First point that we're going to measure is on the input cable. So I'm going to open a little bit the cables here, hold it separately like this. We're going to come with our probe from underneath so you can see it. And we're going to see if the probe is picking any RFI. As you can see, there is right there, the RFI, around 5 megahertz. It's a big chunk of RFI. So I'm going to take the probe out and bring it back in so you can see the difference. So the probe is out. You see, everything goes flattened, and I'm going to put it back in there. And you can see the RFI that we can measure right coming from the power supply feeding this converter, right? Coming in right there, we can see it around 5 megahertz. The big chunk is everywhere because you will see the entire line of the spectrum analyzer goes like a 10 dB down, or maybe a little bit less when I take the probe out. So now the next point that we're going to measure are in the exposed cables. Like we did before, we're going to come from the inside. Right there, you see a big jump on the input, around 4 megahertz. You see a big jump. I'm going to keep moving inside. Yeah, always around all these exposed cables, there is a big jump in noise around 4 megahertz, that area. And if I quickly take this out, the noise goes away, as you can see on the spectrum analyzer. Now, the most important part is, do we have any of these in the output? Let's take a look. Same way of testing like we did in the input. We're going to split the cables a little bit here, and we're going to come from underneath. First here, very slowly, sweeping very slowly all the area under the cables, and there is absolutely no noise coming out of this. So I'm going to try coming from this side. If I come close and further, there is no difference. So it's very, very clean, the output. Even we know the device itself is generating its own noise. We know we are feeding it with a source of noise. And still, you can see it's very, very, very clean. And of course, if we put more ferrites on the output, if I measure here, it should be much less, or not. There is nothing coming out of here. But if we have a little bit, if we put some ferrite beads that should help also to reduce the RFI. So as you can see, I will call this test successful. The filtering that is inside the box is doing its job, apparently. The true test is to test with radios. And now we can connect to the radio and we can see if it's truly not generating any noise. And now for the next test, I put on the bench this 24 volts Chinese power supply, and we're going to do the same thing. We're going to take a look at the output to see if it's any noise coming from this power supply. It's pretty clean. Yeah. Pretty clean with no load, of course. As you can see, the converter is not on, right? So let me try from the other side. If we can see any, there is a little bit of noise in there. Let me take it out and let me bring it in. There, yeah, let me see. Yeah, but there's not a lot. There's not a lot. Let's see, coming close to the power supply. On the side, it's all aluminum, right? And here, the connect, here, yeah. Yep, close to the opening, you can see. Take a look around 4.5 megahertz. When I come close to the opening, there is noise there. So of course it's generating noise. And the noise is leaking from the openings. This is very common in all the electronic devices that they have RFI inside. Any opening on the case will leak that RFI out, and we can see that here, right? So for example, if I go here on the side of the metal, there is no noise. If I go on the openings, look, on the opening of the fan, there is a lot of RFI coming out here. You can see it. When I move along this area, right there, there is a lot of RFI leaking out from the fan hole. We know that this power supply has noise inside. There are not a lot of noise coming out on the cables themselves. So we can see here, this is pretty good. So, but let's turn it on and let's put some load. So now we have almost 24 volts on the input. It's consuming 1.42 amps. It's putting out 13.73 volts, and is the lamp that I have connected is consuming 2.24 amps. All right, now with load, let's see if we have RFI on the cables. Yeah, there is a look at the difference with load. Before we didn't have any RFI. Now when I put the probe, we can see in the same region around 5 megahertz, I think it is. We can see peaks of RFI in the area of 5 megahertz, 6 megahertz. So I remove it and it goes away. Let me see if I can pick up here. Yeah, same thing on the input. Same thing. Let's see in the exposed cables of the device. Look, there is much more than before, and that area close to the 3 megahertz. Going inside, there is a lot of noise inside. Let's see what's happening on the outside. Let's see what's happening on the outside. On the outside, let me come from underneath. There is a little bit of noise around around 5 megahertz. A little bit. If I take out and if I come close, you will see that noise, but there is more there, right? But it's not comparable at all with the noise that we have on the input. I will say the filters are taking 10, I think 90, at least 30 dB of noise from the output, the two filters inside, based on these measurements. Yeah, there is noise there, but There is not a lot, around 5 megahertz, but there is not a lot. All right, let's move to the next device. I brought back this monster Gigabyte supply. This is a 750 watts power supply, able to deliver 61 amps on to the 12-volt rail. This hookup is turned on, and it is delivering the 12 volts to the device. The stabilizer is off. First, I wanted to measure without load the noise, and I am sweeping here the cables, and we can see that, like everything, without any load, there is no noise, right? Because the power supply is idle and is not switching. All right, so now let's turn on our stabilizer. All right, now this power supply is on, and let's start sweeping the device. I'm going to do it here on the connector of the power supply to this adapter. So I'm sweeping here the motherboard connector, the connector that goes into the motherboard. Right here you can see, let me see if I can get it again. Here, there is a lot of noise all over the place, right there. So I'm gonna remove it and bring it close to the same place. And there is the noise. Ranging from 4 megahertz to, I would say, close to 14 megahertz or even more to the right of the middle of the spectrum analyzer. This is not loaded yet. This is just has the load of the converter without the lamp. Now I'm going to turn on the lamp, and you look at the noise, how is even higher now on the output of our PC power supply. Now let's trace this noise to the input here, just to see if we can trace it to this point. There is noise, but there is not a lot here. Let me see on the other one, on the other wire. Yeah, there is not a huge amount of noise coming here, but there are noise coming, right? Let me take this out and bring it close just to see if there's any. Yeah, probably around the 5 megahertz mark is where I see the most noise in these input cables. Let's do the same test we always do here on the exposed cable from the converter. We have our noise right there in the 4 megahertz to 5 megahertz area. So I'm going to move it in and out quickly so you can see how that is jumping a lot. Let me move inside. It's jumping even more in the 4 megahertz area. There is a lot of noise all over the place now. There is noise. You can see here the entire spectrum has noise. Let me see if there's any difference turning on and off the load. Yeah, it goes a little bit down, but not a lot. Let me turn the load back on. And yeah, in the exposed cables, there is a lot of noise. Let's see now how much RFI we have in the output. Yeah, we do have a little bit. Let me see. Yeah, I don't know. Let me try. Here, moving slowly through the cable that goes into our load. There is not a lot of noise compared with the input. So there is a huge difference you can see in all the tests. This is consistent with all the tests on the filtering, right? Again, we have to still test with radios. That will be the final and true answer. This is promising so far. So there is no huge jumps on picking noise like we see on the input. Now we're going to do the test that is the mother of all the tests, that is with the radio itself. Right now, the stabilizer is turned off. As you can see here, the radio is not connected to the stabilizer. The radio right now is connected to a non-switching power supply. It's connected to a regulated Yaesu power supply. And we're going to do a receiving test on all bands to get a baseline of the noise levels and all that. Like, for example, right now you can see in 160 meters, I have a lot of noise and it's coming from outside. It's not coming from the power supply because I'm using a regulated power supply. Right now, we are going to start testing in each band, capturing the baseline noise floor that we have in each band before we turn on and switch the power from the Yaesu power supply into the converter. As you can see, the converter is still off. The radio is not connected here. That is why we're going to take the base floor on all the bands, and then we're going to switch over. We're going to put the audio on of the radio, so we can also monitor that noise with audio too. So in standard 50 meters, this is my noise floor, in my clear noise. 80 meters. 40 meters. 30 meters. 20 meters. This is a contest today, so there's a lot of activity. 17 meters. You see, I have a lot of noise on 160 meters and 17 meters. Now 50 meters, still I have noise. You can see all the little peaks across the entire band. And now 12 meters. Now 10 meters. And we're going to stop here on 10 meters. And now, as you can see, the converter and stabilizer is on. The radio reception mode is consuming less than the A57D. This is something worth noticing, right? This radio consumes less in receiving mode and the standby mode than the FT A57D. Only 400 milliamps. The noise in 160 meters, it looks similar to the previous measurement. We're gonna go across all the bands like we did before, and then maybe I can put side-by-side comparison, taking screenshots from the video. Let's switch to 80 meters. There is nothing different in here that is obvious. It looks the same. I cannot hear noise, no noise. 40 meters. There are no birdies or anything. 30 meters. You see, screen across the band, no birdies or anything like that. 20 meters. The band is more congested because of the contest, but you cannot see any kind of birdies or anything. There will be parallel lines across the display separately so often. You cannot see anything like that. Just the normal signals. Let's go to 17 meters. Here is the same noise floor as we had before. We have a lot of noise on this band right now. 50 meters. It looks exactly the same. Sound is sounding exactly the same. No birdies. 12 meter band. Very similar. And lastly, the 10 meter band. Again, no birdies, no extra noise on the audio. It looks good. All right. So here I have side by side the two clips. So let me run the two clips so we can see side by side how they run. On the top left, we have the clip with the radio directly connected to the Yaesu regulated non-switching power supply. And in the bottom right, we have the radio connected to the Yaesu power supply, but this time not directly via the stabilizer using the DC-DC converter on the unit. I'm going to try to keep those two clips in sync. First, we are in the 160 band. We can see this is exactly same noise. This is very noisy for me, so very hard to see anything else. We'll see other bands. All right, so now we see side by side 80 meters. Now we can see side by side 40 meters. And now we can see side by side 30 meters. And now we can see side by side 20 meters. They all look same to me. Now we see side by side the 17-meter band, which is pretty noisy on my end in general. Now we are looking side by side on the 15-meter band. Switching now to 12-meter. And finally, this is the last one, taking a look side by side to the 10-meter band. This is pretty good. I will say this is a very successful test. The radio is not getting any extra noise from the converter. Of course, I use a regulated non-switching power supply as my input because that will be the baseline, right? To see if the converting is adding noise on top of what is already coming from the power supply. Since the regulated power supply is silent, we can see that there is no added noise on top of the power supply. The other thing that you will see earlier on this video is that even the switching power supply that we test, the noise, it was cancelled at the end. It was present at the input, but it was not present in the output. So the filtering units that we put, the suppressors that we put inside, seems to be working fine as we test once again. And I will call this a successful build. So I hope you like this testing. I hope you learn how you can do your own testing with very cheap tools like I did. And if you like, leave a comment, like the video, subscribe to the channel, and thanks for watching, and until the next time.